Hello guys, welcome back. In this video, I'm going to show you what is the divide and conquer paradigm about. So the divide and conquer paradigm is basically when you have a big problem, right? And to order to solve the problem, you could go and do brute force. Let's say you do brute force, right? So brute force, what we do here in this case, imagine we have a lot of things inside an array, right? So it will iterative go from one item to the other item, all right? Or maybe go from this way to the other item. And so what he's trying to do Reinforce here is to try all possible, all right, solutions until we find an answer. All right, so that's why most of the time you want to use brute force when you want to prove something or you want to find a solution quick, let's say, but it is not great because it will give you a time complexity, sometimes quadratic or even more. All right, I think the best cases will be linear, but we want to find something better. We want to find a, let's say, a time complexity of logarithmic, right? So in order to find something like this, that's why we would start using divide and conquer. So divide and conquer, instead of doing all of these, right? Instead of going through all of the items inside an array, let's say, what it's going to do, right, is simply split the problem, which is right now big, split it in sub problems, right? Split it in small sizes of the problem that has the same time complexity or maybe less. So for example, let's say that we are trying to find where a x number is. It could be here, it could be here, or it could be here. So you don't know. Instead of going through all of the array, what you can do is split it in half, and then you have two, all right, you have two, let's say two subarrays containing one middle and then the other half, right? And then you would still do the same and do the same, do the same. So this is kind of similar what we have seen in previous videos. Here, for example, about merge sort, which uses divide and conquer, or what is used in quicksort, all right, which is also using here divide and conquer, whether you have the Lumut version or the Tomiho version, all right. So most of the times these algorithms using the divide and conquer paradigm, they are most of the times, all right, you want to program them recursively, right? You want to be recursive, right? Because it is more human friendly for reading, and also sometimes languages are optimized for recursive function instead of doing iterative. But remember, okay, remember that every recursive algorithm can be iterative. So here is what you will use, something called the stack code, all right? But for now, we're going to focus on doing these problems recursively, all right? So if you don't know what recursion is, I will show you the next video probably. So right now, let's focus on this problem. So the statement goes like this. We're given an array of integers named nums, all right? They say that we are asked to find an unknown target number x, all right? So we don't know what the number is. But we know that x, all right, is greater or equal than c, and f is greater or equal than our x. So all variables are integers, all right? So variables meaning f, x, and c, they are positive. And use a function, and then we asked also to use a function named less or equal than, which upsets one variable here named m, all right? And this function, what returns is true only when this is met. So when we have x and that x, or our number, or such number, is less or equal than m. That's why it is called less or equal than m, right? Referring to the x. All right, so let's try to do this with a small array. Let's imagine we have 2 and then 4 and then 7 and then 8. All right, so let's say that our x is 4. All right, so instead of going through or let's say our array is 8, or our x is 8. So instead of going from the first index until we find it, what we're going to do here is something called binary search. All right, binary search. So what binary search is about is basically what I explained later. You split, all right, you split the array in half, all right, and then what you're going to do is do a function, all right, is do a function, execute a function after splitting this in half. So how can we split the array in half? So what we're going to do is basically do what is called a median of 3. All right, a median of 3. All right. So basically what you're going to do is select the first index, all right, which is 1, and then the last index, which is 4, divided by 2, and do either a floor function or a ceiling function. I rather do a floor function. All right, so I'm going to do that, and what we're going to end up is with 2. So we're going to do here, go to index 2, and this is going to be our pivot, let's say. So this is kind of similar to quicksort, where you just go and search a pivot, where you start from you search it on let's say on the center of the array. So it's kind of similar to what you do to quicksort, but you're not going to put this at the end, right? So what you're going to do here, all right, after selecting one pivot, let's say that is the middle, all right, what you're going to do that here is question this pivot. You're going to question this pivot how? With the function we are given. So you're going to say less equal than, and then we're going to send this pivot. All right, we're going to question this pivot. Why? Because the function is this function is good for us because it's telling us where that pivot is greater than the x. So this can be written as this as well. All right, so if this is met, this is going to return true. So basically we're going to send our pivot, and we're going to ask, is that pivot greater than x, the number that we are searching? If that is true, all right, if that is true, so that means that this pivot is greater than x. So that means x should be in this way, all right, left to the pivot, because the pivot is greater. So what we're going to do here is execute or recursively execute the same function, but from C, which is this is going to be our C, all right, and this is going to be our F. So basically C should be the start, all right, the start of the array, and F will be the end of the array, because we are given that this C, all right, is less than the X that we are looking for. So we should start from C, and then we are saying that F is greater than X, so we should end until the F. So what we're going to do here is basically execute the same function, but from C until the pivot. All right. If it's false, so that meaning that the M is or the X is greater than the M, all right, then we are on this case on the right, meaning that the X is greater than the pivot, meaning that it should be on this side. So you're going to do pivot plus 1, because we have already questioned that here, so that's why we sum until the F, right? So how can you write this down on code? We are going to do some pseudocode, all right? So basically what you're going to write down, right, is the name of our function. Let's say function guess x. So we are given, all right, C and F, which are the first index and the last index, let's say, value. And then we're going to do a base case. So after that, before that, we're going to do what we have already explained. So we're going to find pivot. So I'm going to write it as mid, right? Where I use these two numbers divided by 2, and then I use the ceiling, the floor function, all right, to select a mid item. And then we ask that mid item, all right? We ask that mid item with the function less equal, all right? We ask that item, we asked. What we're going to ask, we asked if that item is greater or less than x. If it's greater, so that means it should be on the left side. So we're going to ask again the same function, guess x. All right, it's going to start from C until mid. If it's false, all right, we do to the right side. So we start at mid plus 1, all right, and then we end until f. So and then what happens if you keep constantly breaking, all right, you keep constantly breaking this in half, and then you break this in half and in half, you will end up with just one, all right, one item in an array, all right. So imagine that you have already break this in half, right? So you have 2 and 4 on this side, and then on this side you have 7 and 8. You know that the pivot is on the right side, so it's going to go here. So you have 7 and 8. You ask the same, and then you go and select a pivot again. Let's say you select 7, right? So you ask 7 here. If that 7 is greater than than our x, no. Well, in this case, x will be bigger than our 7, of course, because x is 8 in this case. So we're going to end up here again, all right? So that's going to be mid. We select a 7, so 7 plus 1 is going to be, or the index is going to be 2. So we're going to ask 2 and 2, all right, as this. Guess x is going to receive these two arguments. So C and F is going to be the same because we are given here, we are splitting this in half, and then we are going to give this function just an array of one item, which is going to be 8. So in that case, 7 and F are going to be the same because there is only one item. So that's why we ask here, if you happen to find, all right, an array where C and F are the same, so that means that is our number. So we can either return C or you can either return F. Let's return C. So that's it. That's how it ends. So basically, all right, basically what we have done here, all right, is a binary search. All right, and it is even better than common binary search, right? Because why this is better than binary search? Because in binary search you don't have this function less or equal than m, so you have an idea if the number you are finding, all right, is less or equal, and you're given the number instead. You don't have to guess. So it really depends on the case. But well, that's it, guys. Hopefully you understood, and thank you for watching.